In this video, we will continue practicing solving trig equations. This first one is next level. Before we dive into that, let me remind you there's some information that you have to basically have memorized. This is one set of information, our Pythagorean identities and their variations. You should be able to generate a chart like this in under a minute and a half. And similarly, then there's this set of information. You need to have this memorized as well, or at least be able to generate the chart in under a minute and a half. Now, back down to business. We need to get 0 on one side because we can't divide by a trig function. So, for example, I can't divide both sides by cosine. All we can really do is get 0 on one side. So I'm going to subtract 2 cosine x from both sides like so. At this point, I have radical 3 cotangent x minus 2 cosine x is equal to 0. Alright, I have to admit that at this moment I have no idea what I'm going to do. So I'm going to just try some stuff. So cotangent, I know that that is cosine over sine. So let's see what happens if I rewrite. So now I've got radical 3 times cosine x over sine x. And I'll just go ahead and put the radical 3 in the numerator. And then meanwhile over here I have minus 2 cosine x. And I'll just put that over 1 just for fun. And that equals 0. So if I wanted to put these together, I would need like denominators. So the way that would happen would be if I multiplied both sides by sine x. Okay, so now I have like denominators. So if I put these together, I would have radical 3 cosine x minus 2 cosine x sine x all over sine x. And this equals 0. Now, I'm thinking about what to do next, and the only thing I can really see, by the way, you can't cancel out these signs. That's a common mistake that students will want to make. Because these are connected by a minus sign, you cannot cancel these out. But because both of these have cosine in them, what I could do is factor out cosine as a GCF. So that's what I'm going to do. I'm going to factor out the cosine. So if I take the cosine, put it out front, then what I have is cosine x outside the parentheses. Then inside the parentheses I have radical 3 minus 2 sine x. Okay, and this is going to be over sine x. And that equals 0. Okay, this is real interesting. One thing I see that I can do is if I sort of group these together, alright, then what I have is cosine x over sine x times radical 3 minus 2 sine x. So I didn't really change anything, I just changed the look of things. But if you think about it, this is the same as what I had a moment ago. If I were to put a 1 under this and multiply them together, you can see that I would get right back to what I had before. Alright, cosine times the parentheses and then over sine x. So I didn't change anything. But what I can do now is I can use the zero product property. If I have something times something equal to 0, I can set each 1 equal to 0. Oh, and while I'm at it, this is cotangent. So I could say cotangent x is equal to 0. Alright, I'm setting the left side equal to 0. And I can say radical 3 minus 2 sine x is equal to 0. I can just solve these separately. Let's go ahead and deal with the cotangent first. If cotangent is going to equal 0, here's my diagram for this. Alright, I'm looking at the quadrantal angles here and here and here and here. This is 1 comma 0. This is 0 comma 1, negative 1 comma 0, and 0 comma negative 1. Now cotangent is x over y. So the cotangent here would be 1 over 0, 0 over 1, 0 over negative 1, and negative 1 over 0. Alright, just in each case I'm doing x over y. However, 1 over 0, this is undefined. So I'm just going to put a big X through that. That's undefined. Same with this. You can't divide by 0. That's crazy. Get that out of here. However, 0 divided by 1, that is 0. And same with 0 divided by negative 1. So these two angles are actually solutions. So this is a solution and this is a solution. So that gives me x is equal to pi over 2 or 3 pi over 2. Alright, so that's two solutions so far. Now, let's see what kind of solutions we can get from the right-hand side. So I can solve this by subtracting radical 3 from both sides. So that's going to give me negative 2 sine x is equal to negative radical 3. Next, it's time to divide both sides by negative 2. So these are going to cancel out. And that's going to leave me with sine x is equal to radical 3 over 2. So it's time to ask yourself, what is the reference angle? Sine of what is radical 3 over 2? Well, that is going to be pi over 3. Sine of pi over 3 is radical 3 over 2. So that's the reference angle. So now we know that the reference angle is pi over 3. So here's a diagram for you. Alright, there's pi, and here is pi over 3. So there are 4 angles that have a reference angle of pi over 3. And here they are. Since we're talking about sine, these two will be positive, and these two will be negative, because sine is a y value. In this case, we want a positive sine, so these will be the solutions. So what do we just find? X is equal to pi over 3 or 2 pi over 3. So altogether we had 4 solutions. Pi over 2, 3 pi over 2, pi over 3, and 2 pi over 3. Number 14 seems a little bit more straightforward. It looks like it's ready to factor right now. Let's go ahead and give it a shot. 2 cosine squared. That can only factor as 2 cosine x times cosine x. And now 2. 2 can only factor as 2 times 1. Now I know not to put the 2 here, because that would cause a common factor inside the parentheses. And if there's no common factor in the original problem, there should be no common factor inside the parentheses either. So I won't waste my time on that guess. Instead, I will go 1 times 2 like this. Inner plus outer must equal middle. Inner, I have 1 cosine x. Outer, I have 4 cosine x. I'm shooting for a middle of negative 5 cosine x. That will happen if both of these are negative. So negative and negative. Also, negative 1 times negative 2 is positive 2, so it works. So now that I have factored it, I can use the zero product property. So 2 cosine x minus 1 equals 0, or cosine x minus 2 is equal to 0. Adding 1 to both sides, I have 2 cosine x is equal to 1. Dividing both sides by 2, I have cosine x is equal to 1/2. In the meantime, adding 2 to both sides, I get cosine x is equal to 2. So now I just need to solve each one of these. Cosine of what angle is 1/2? Well, the reference angle is pi over 3. Notice that the cosine of pi over 3 is equal to 1/2. So that's not the answer, that's the reference angle. So now that I know that the reference angle is pi over 3, I can draw myself a little diagram, and it will be a diagram of pi over 3. There are 4 angles that have a reference angle of pi over 3. They are here, 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 and here. Cosine is the x value on the unit circle. So these two will be positive because they're to the right, and these two will be negative. In this case, I want the positive version, positive 1/2. So these two will be the solutions. So that tells me that x is equal to pi over 3, or x is equal to 5 pi over 3. And what about cosine of x is equal to 2? Well, hopefully you will recognize right away that we will get no solutions from this. Alright, this has no solution. Because, I mean, think about the unit circle. Cosine is the x value, 1, 0. For example, 0, 1, negative 1, 0, 0, negative 1. Now, so the cosine, here the cosine is at its highest value of 1. And as we go around the unit circle, it goes down from 1 down to 0, and then it falls to its lowest point of negative 1, and then it comes back to 0, and then it just repeats, and it just keeps oscillating between 1 and negative 1, 1 and negative 1. It never gets higher than negative 1, and it never gets higher than 1, it never gets lower than negative 1. So there's no angle that will ever give us a cosine of 2. So don't put a box around that, because that makes it look like you think there are no solutions. But we already found 2 solutions. So this is the answer right here, and this is just our work showing that we won't get any additional solutions from this part of it. But that's the answer. This next problem is going to take a little bit more thought because I see that we have secant and tangent within the same problem. I have a feeling we're going to use our Pythagorean identities in order to turn this into all one type of function. I see the secant squared, so that's what we have to work with, secant squared. So let's see, secant squared is equal to 1 plus tangent squared. So let's make that substitution. Alright, so here is secant squared. I'm going to take that and replace it with 1 plus tangent squared. Alright, then I have the rest of it. So I'm just going to bring down the tangent x and the minus 1 and the equals 0. Looking for like terms, I see the 1 and the negative 1. But look, they just cancel each other out, don't they? So those are gone now, and so now I just have tangent squared x plus tangent x is equal to 0. So the thing that's jumping out at me is the only two terms I have both have tangent. That is a common factor, my friends. So I'm going to go ahead and take tangent x and pull that outside of the parentheses. So that's going to leave tangent x plus 1 inside. And guess what? That's factored. So I can use my zero product property. So tangent x is equal to 0, and tangent x plus 1 is equal to 0. Subtracting 1 from both sides real quick gives me tangent x is equal to negative 1. Now let's take a look at the unit circle and see what we've really got. So here's the unit circle. Alright, so I'm looking at this one first. I want to know where tangent is going to equal 0. So this is 1 comma 0, 0 comma 1, negative 1 comma 0, and 0 comma negative 1. Remembering that tangent, alright, if I say tangent theta, just to not get it mixed up with this x, tangent is y over x in general on the unit circle. You know, it's sine over cosine. So using that fact, y over x, so that would make this 0 over 1 and 1 over 0 and 0 over negative 1 and negative 1 over 0. Now you can't divide by 0, guys. So that's undefined. Both of those are undefined. But this one is going to equal 0. And this is also going to equal 0. So if I want the tangent to be 0, I have found two solutions. One here and one here. So let's record those solutions so far. So I have x is equal to 0 and pi. Okay, so I have these two solutions so far. Now let's look at tangent of x is equal to negative 1. What is the reference angle? Tangent, we'll ignore the negative for a moment. Tangent of what angle is equal to positive 1? Well, that's going to be pi over 4. Oh, that's the wrong chart. Tangent of pi over 4 is 1. Okay, now this is negative 1, but still that tells me the reference angle. Let me just erase this for a minute. Okay, so because the tangent of pi over 4 is equal to 1, I know that pi over 4 is the reference angle. So what I'm going to do is I'm going to draw that diagram. So pi over 4 is the reference angle. So that's why I'm going to draw pi over 4. So here's pi over 2, and here is pi over 4. there are 4 angles that will have a reference angle of pi over 4. And they are here, 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 and here. The tangent of any of these angles will be some kind of 1. But these 2 angles will give me a positive 1. And these 2 angles will give me a negative 1. In this case, we want the negative 1. So we have solutions here and here. So we will add those solutions to our list. So x equals 3 pi over 4 or 7 pi over 4. So altogether we have these 4 solutions to the question. Alright, let's do one more problem, and that is going to do it for this video and this series of videos. So I notice that we have cosine and sine. So again, I think we shall use our Pythagorean identities to convert so that we have all one kind of function. Now, cosine squared x, that's the only thing that I'm going to find on my chart here. So that's what I'm going to use. Cosine squared is equal to 1 minus sine squared. So let's make that substitution. Okay, so cosine squared is equal to 1 minus sine squared. And then I have the rest of it. Plus sine x is equal to 1. Alright, so now I have all one kind of function. Let's get 0 on one side. So I'm going to subtract 1 from both sides. They both cancel. So now I have negative sine squared x plus sine x is equal to 0. Now, I'm more comfortable when the first term is a positive leading coefficient. So I don't have to do this, but I will feel better if I divide everything by negative 1. So that's going to make this become sine squared x minus sine x is equal to 0. Ah, that's better. That just seems a lot better to me. Now, I see sine in both places. So sine x is a common factor. That's why I'm going to go ahead and bring sine x out front. And that will leave sine x minus 1 inside the parentheses. Now, since we've factored it, we can use the zero product property. Sine x equals 0, that'll give us one solution. Sine x minus 1 equals 0, that will give us another solution. Solving this quickly by adding 1 to both sides. Here I have sine x is equal to 1. Let's investigate. Both of these look like they are dealing with quadrantal angles. Alright, multiples of pi over 2. So once again, let's check it out. So this is 1 comma 0 and 0 comma 1 and negative 1 comma 0 and 0 comma negative 1. Now sine is the y value on the unit circle. So let's see. If I want the sine of x to be 0, then I'm checking the y values and I'm looking for 0. And I see that I have 0 right here and I have 0 right here. Those are the only two y values where I'm going to have the y values are 0. So I have found two solutions. I have a solution at angle 0, and I also have a solution at pi. So I have these two solutions so far. Okay, now let's rewind. I'm just going to erase those marks. Alright, now sine x equals 1. So same concept, but this time we're looking for a y value of 1. No, yes. There's a y value of 1. No, no. So this is the only angle that has a y value of 1. So this is the only solution. So x equals pi over 2. So that's a third solution. So altogether we have three solutions: 0, pi, and pi over 2. That is going to do it for this video, guys. I hope it was helpful, and I hope to see you on the next video.